way, and then once that row gets them, they'll pass them up. That way you don't even have to go.
Wow.
So no congestion at the turn and big.
You look smart already.
All right, so I am going to have Marie, come on up, girl. So, before we start this equation, this is the exact same thing we've been doing, it's just in a different format. So if you felt confused, kind of sit back and say, what do I know about this equation? Because you actually know a lot about it. So, Nairi, what is the very first thing that you did? She found the R, so she noticed that if you take 12 divided by 3, what happens, Mary? You get good. And she wanted to double check. So she did that, and she still got, so she told me first she found her R, and your R is perfect. So she found her R before, so she still needs an A1. What does A1 stand for? The first term, and it is perfect. And so when we go ahead and we plug it into this equation, you can go ahead and write it on there if you want, or you can circle which one it is. That works too. Yeah, it works with the pen. I'm gonna find my pen though. There we go. Look at that. Okay, so what we have here is you're good. You're on your own. We have that I found my pen. Thank you. We have that it's growing exponentially. We know if something's growing exponentially, how? Is it gonna be? That's exactly what I was looking for. So something's growing exponentially if it's multiplied or if it's dividing. And how do we know something's growing linear? Added or subtracted, yep. So this would be a, what kind of equation? Geometric, and it's, okay, so geometric is what kind of equation? Exponential. Perfect. All right, so today we're gonna kind of totally switch gears. You have a really big notes packet to help you. So today I will add and subtract so I can simplify polynomial expressions, and we will know it when we can show 80% mastery on method taking. So we're totally switching gears. We're going to go over a chunk of vocab at the beginning, and then we will start working with these. But first we want to know what we're working with. So make sure you write that very first word down so it's highlighted and it's not very clear on your page. First word is monomial. Monomial. And can someone read to me, Ramses? I'm going to pick on you. Can you read to me what the definition of a monomial is? It's on the board too, Ramses.
Oh, a single term separated from other terms by addition and subtraction.
Yeah, a single term separated from other terms by addition and subtraction. So, you see how like this is alone? If this was part of an equation, we'd have addition or we'd have subtraction after it. Okay? So if you look like further down on your page, like right here where it says like terms, you see that? Like you see how there's addition and subtraction between each one? That's what we're talking about, okay? So a monomial is a single term separated from other terms by addition and subtraction. Make sure you write monomial because I think it's kind of hard to see on your sheet of paper, okay? Now we have a polynomial, which is more common. So can I get Alex to read me what a polynomial is? Just this whole slide.
Multiple monomials.
Yep. And Zaire, can you tell us what we do with them? Just read it. You don't have to make it up. You're good. I'll explain it to you. Okay, so we left off a little bit here, but we are going to convert them to standard form first. So we are going to combine any like terms that we have, which is what we would call simplification. And then we're going to add and subtract the coefficients. And we're going to order the exponents. So we want our exponents to go from the highest exponent to the lowest exponent. So examples of like an exponent would be the number 12, 7, and 2. Like we want it to go 12, 7, 2. Not like 2, 12, 7. We want our exponents to be in order. And this will all make a lot more sense once you look at an example of this. But for now, you have this right here to show you that they are going in order, okay? So, that's what we got for you, polynomials. So, looking at this, we are talking about exponents. Do you see how there's an exponent right here at the end? And exponent here, here, and so on. We want to, like what we just did on the last slide, we want to make sure that our exponents are in order from largest to smallest. So which one should be at the beginning of this?
2,
3. So like this would be the monomial. This term would be at the very front. So it just like when you're reading it like math-wise, it like pleases your brain to have everything in order, okay? So typically, if I were you, what I would do is I would do the equation, and then I would go back and I would do it in order, because I think when your brain's trying to do two things at one time, that is where an issue can usually happen, okay? So, like terms. You guys know about what like terms are, but we're going to take that to like the next step now. So, Allison, can you read me what a like term is? Yeah, so that has the same letter and the same exponent. So like everything about them at the end has to be exactly the same. This very first number doesn't have to be the same, but everything about them after that number has to be the same. Did I say that right? I meant that. So if we look at this, we have an x squared here, and we have an x squared here. So what's our vote on if those are like terms?
Combine.
Somebody said combine them, so you're telling me they are like terms, right? So we have an x2 here, and we have an x2 here, so they have the same term, so can we combine them?
Yeah.
Yes, so Justice, what would these combine to be?
5.
Yeah, so this would be 5x squared. Is that what we said? Okay, so we, like about 3 weeks ago, learned about the exponent rules. When you're adding terms, your exponents are going to stay the same. And remember when we multiplied terms, we added the exponents. When we divided, we subtracted. Yes? You guys are pretty good at that. Alright, and then do you see how this x here, like, it's alone. It doesn't have any friends. Do you see that? We can't combine with anything on this side, right? So we're just going to put it down here. Okay? On this side, is there anything that we can combine?
No.
Nope. So what should I do? Rewrite it, and Island was telling me the answer. So now that we've simplified this, is this the same thing?
Yeah.
Okay, so you could solve if you want, but you get 0 equals 0, but the point of this is to show you that you can't really solve for an equation unless you've combined all of your like terms. And I think that when we just did geometric equations and we distributed and we had to combine, it really helped us to get the right answer. So that is the whole point of this. We want to make sure that we have the perfect final answer. So, going back over this one more time so we're sure, we want our exponents to go from largest to smallest. So, what is our largest exponent on this one, Brainy? Yeah, perfect. She told me the whole term. That's perfect. So, 15b minus 7 is our largest one, so it is going to go to the very front. So, do you see how up here, these are out of order? Our exponents, like we have a 2, a 4. What would be attached to that b?
1.
Beautiful. 1. So now they rearranged it right here. Do you see how they're in order?
Yes.
So this is not the correct answer. The correct answer has all of your exponents in order. Okay? So just make sure you double check your work. And more vocab. We're almost done with vocab, I promise. So we have a leading coefficient, which is the number in front of the term that has the largest exponent. So in this case, our largest exponent is 3. So we call that to a degree of 3. And our leading coefficient is 4. And we know our leading coefficient is 4 because that is the term, that's the number that's in front of our term with the highest exponent. Okay? I swear, we're getting to math soon, I promise. So this kind of breaks it down and tells you like the technical math terms for each one of these. So if you have one term, it's a monomial. If you have two terms, it's a binomial. Three terms is a trinomial. And anything after that is a polynomial. So if there's 20 terms, it's a polynomial. If there's 4 terms, it's a polynomial. So Ramses, what do we call something that has one term?
Monomial.
Perfect. John, what do we call something that has 9 terms?
Polynomial.
Beautiful. Alan, what do we call